Hello student, welcome back to my channel Kunal sir at JEE NEET Chemistry World. As the JEE main is progressing, today is the second day fast shift, but now I am going to discuss yesterday's evening shift paper, that means 21st January evening shift JEE main chemistry paper discussion. Now if you look at here, they given one questions. The correct order of radius, aluminum is greater than magnesium, is greater than magnesium plus 2, is greater than magnesium plus 3. Generally left to right in a periodic table, Z star effective will increase, that's why size will be decreases. Whereas top to bottom number of cell increases, that's why size will be what? Increases. Now if you look at aluminum, this is the third period element. If you look at that, aluminum and after that there will be magnesium. Magnesium is there, first magnesium, and after that aluminum. Magnesium atomic number is 12, aluminum is 13. Now if you look at, they are telling the correct order of radius of aluminum is greater than the magnesium. Now if I look at the group boron, aluminum, gallium, indium, thallium, whereas if you look at the magnesium position, so magnesium is before the aluminum. Magnesium is before the aluminum situation because magnesium is second period element. So now here beryllium, magnesium, like that situation will come. Beryllium, magnesium, calcium, strontium, barium, like that it will come over here. Now they are telling aluminum has a bigger size than a magnesium, where is magnesium has a greater size than the magnesium plus 2 and magnesium plus 2 has a greater size than aluminum plus 3. The two statement is there and statement 2 is there. Atomic size always depend on the electronegativity. This is wrong. Atomic size will not always depend on electronegativity. Now if you look at aluminum and magnesium size, your situation is here you have a beryllium and after that boron, carbon, nitrogen is going on, and now after that boron, aluminum. This is your situation. Magnesium is over here and aluminum is over here. This is magnesium atomic number 12, aluminum atomic number is 13. After that silicon is present. They are telling aluminum the correct order of radius. Aluminum is greater than the magnesium and the magnesium is greater than the magnesium plus 2 and magnesium plus 2 is greater than the aluminum plus 3. And option was there, statement 1 and statement 2 is correct. Both statement 1 and statement 2 are incorrect. Actual order will be, if you look at very carefully, actual order will be magnesium will be greater than the aluminum if same period element is there. I think here the question they give properly, this order will be magnesium is greater than aluminum and then only your situations will come, then magnesium plus 2 greater than aluminum plus 3, then only statement 1 will be correct, otherwise it is not. Now that's why if it is there aluminum is greater than magnesium, the correct order of radius, so the idea is left to right size will be decreases, at the Z star effective will be increases. So atomic radius is magnesium is greater than aluminum. You look at here also is there, magnesium is greater than aluminum, is greater than magnesium plus 2, is greater than aluminum plus 3. That's why I told in question this one should be magnesium. So magnesium is greater than aluminum and then Mg plus 2 and Al plus 3. Then only the statement 1 will be correct and statement 2 will be incorrect. Third option will be the answer. Here I think some printing mistake or something is present over there. Point is clear. Basic funda, left to right size will be decreases, top to bottom size will be increases. Now come to the second questions. Here they are giving significant figure of summation of these 3 figure 0.153, 153.2 and 1532. Simply you will add it up these things. That means you have a 0.153 and then 153.153.2 and then 1532.0. These will be your added. Then 3 and then 5, then 3, then you will get 325 and then you will get 538 and 516, 168.35. Now 168.35 nearly equals to, I can write down 1685. So then summation will be coming how much? 1685. How many significant figure? 4 significant figure. That's why your answer will be the 4 significant figure will be present, summation of all these figures. Point is clear? Okay. Let us go to the next question, which is coming from the crystal field stabilization energy from coordination compound. Now here there is statement 1 is telling crystal field stabilization energy magnitude wise, cobalt with water, and cobalt is in +2 state and nickel also is in +2 state octahedral complex. Now if I look at the octahedral complex, the octahedral complex splitting, then what you will get to know over here? You look at carefully. We know very well in octahedral complex, the d orbital, the degenerate 5 set of d orbital will be split into 2 level due to the octahedral field, and you will get the T2G and EG, and based on the ligand there will be different types of electron filling order will be there, because if the ligand is a strong field, then against the Hund's rule pairing will be there and you will get the low spin complex, whereas if the ligand is weak field ligand, then against the Hund's rule pairing will not be there, you will get the high spin complex, and you will, based on that, different kind of crystal field stabilization energy you will get. Now if you look at that, the 5 sets of d orbital in octahedral complex, it will split into like this level. You know very well, these are the dxy, dxz, dyz at a together we will call it as a what? T2G, and this is your dx2 and dz square, because in octahedral field ligand is approaching along the axis. That's why along the axis orbital is suffering more interaction with the ligand, and then their energy will be what? Increases. And then this is your EG. Now cobalt in between energy difference we will call it as a delta naught. This is your barycenter. This is -2/5 delta naught per electron stabilization. From here to here this stabilization, and here to here this is +3/5 delta naught. Delta naught is the energy difference between EG and T2G. Now you know very well, here they are giving cobalt H2O6 +2 complex. Cobalt is in +2 state, H2O is a neutral ligand. So that's why cobalt has a valence electron 3d7 4s2 neutral state. Now cobalt is in +2 state, that's why there is a d7 and 4s0 configuration. 7 electron is present, and the ligand is a weak field condition. If cobalt is there in a +3 state, then only H2O will act as a strong field ligand, but here cobalt is in +2 state, that's why H2O is acting as a weak field ligand. So now in cobalt situations will be there. If you look at cobalt H2O whole 6 +2 situation is a D7 configuration and weak field situation. Then immediately weak field means how it will fill it up? 1, 1, 1, 1, 5 electron, then 6, 7. That means your situation will be T2G. How many electron? 5, EG 2. This will be situation. Now if you calculate per electron stabilization is there -2/5 delta naught. So if due to ligand there is a no pairing is there, that's why your CFSE expressions will be, CFSE expression will be equals to, so how many electron? 5 into -0.4 delta naught plus how many electron? 2 electron in EG, 2 into plus 0.6 delta naught. Overall value if you calculate 0.4 into 5, which is nothing but a 2 delta naught, and here 2 into this is minus 2 delta naught and plus 1.2 delta naught. Overall is coming minus 0.8 delta naught. Whereas nickel H2O plus 2 complex, nickel H2O plus 2 complex means nickel is in D8 configuration, because nickel in neutral state D8 4s2. Now plus 2 state means D8, 8 electron and weak field ligand. Then how it will be fill it up? Same way, 1, 2, 3, 4, 5, 6, 7, 8. That means in nickel H2O whole 6 plus 2, here my situation will be T2G6, T2G6 and Eg2. That will be my situation. Like how you will fill it up? 1, 2, 3, 4, 5, 6, 7, 8. T2G6 and Eg2. Then my CFSE expression will be 6 into minus 0.4 delta naught plus how many Eg? 2 into 0.6 delta naught, where there we will get minus 2.4 delta naught plus 1.2 delta naught. Overall value is coming minus 1.2 delta naught. That means CFSE is coming more in case of a NiH2 whole 6. That means NiH2 whole 6 is more stability compared, has a more stability compared to cobalt H2 6 2 plus. But here they are telling crystal phase stabilization energy of this COH2 whole 6 is greater. This is the wrong statement. NiH2 whole 6 is greater, which is nothing but a minus 1.2 delta naught, whereas cobalt H2 6 plus 2 is coming minus 0.8 delta naught. Whereas statement 2 is telling order of bond energy, chlorine is greater than, bromine is greater than, fluorine is greater than, and iodine. This statement is true. Why? Because fluorine small size, overlap will be more, so bond strength will be more, bond length will be less. But the fluorine has a lone pair repulsion, like this situation. Fluorine will have a lone pair repulsion, like this. Repulsion will be there. That's why bond dissociation energy will be lower than the bromine, but little higher than the iodine. That's why that order is a correct order. That's why statement 1 is incorrect, statement 2 is correct. Fourth option is ready for your answer. Is it clear? Everybody clear? Okay, let's go to the next questions. What they ask into the next questions. Now, if you look at the next question, they are giving 8.74 gram MnO2 is treated with HCl, then what will be the weight of chlorine obtained? Now, for this type of thing, this question is physical chemistry question, basic concept of chemistry, stoichiometry related question. You have to write down the balanced chemical equation, then only by mole concept you can catch it up the problem. Now, if you look at, first you write down the balanced chemical equation. What is that one? Balanced chemical equation you need to write down. What is that one? The balanced chemical equation, MnO2 plus 4HCl, on reaction it will be converted to MnCl2 plus Cl2 plus 2H2O. It will form like this. Now you look at manganese balance, oxygen balance, chlorine balance. We got the balance equation. Now they are telling 8.74 gram of MnO2. That means what is the number of moles of MnO2? Number of moles of MnO2 will be equal to given it by molar mass. 8.74 by molar mass of MnO2 they provided. If they not provided, you have to find out. Manganese is 55.5 plus oxygen O2 is 32, 87.5. But they are giving 87.4. You have to consider that one. Then 87.4. Immediately if you find out, it will get 0.1 mole of this. Then 1 mole of MnO2, 1 mole of MnO2 liberated 1 mole of Cl2. Obviously 0. will liberated 0.1 mole of chlorine. Then 1 mole of chlorine weight is 35.5 and then 0.1 chlorine will be weight, 1 mole of chlorine weight is 71 gram. Chlorine, not chlorine atom, chlorine molecule. So 1 mole of chlorine weight is 71 gram. Then 0.1 will be how much? 7.1 gram. Then that your answer will be how much chlorine obtained they are asking. Your answer will be how much? 7.1 gram. Come to the next question. They are giving, find the concentration of X2 minus at equilibrium in 0.1 molar of H2X. Very nice question. Now you look at, this is question is based on ionic equilibrium. And now you look at how we can solve these questions. Look at, first let me delete this question so that we can solve over here itself. We can easily solve these things, so that easily we can write down the how we can solve these questions. Now you look at, now here they are giving, find out the concentration of X2 at equilibrium 0.1 molar of H2X. That means H2A is like a weak acid, H3PO4 or H2CO3. First it will undergo step by step manner dissociation. This will give H plus, with that HX minus. Now we know very well, if the concentration is C, here concentration is giving 0.1. How much will be dissociated? 0.1 alpha 1. This is the first dissociation. 0.1 alpha 1. Here H plus will be how much? 0.1 alpha 1, and this will be 0.1 alpha 1. This is for the first dissociation constant K1. Then immediately I can write down my K1 expression will be equals to H plus concentration into HX minus concentration divided by H2X concentration. Now that value, all value we know. This is 0.1 alpha 1. This is also into 0.1 alpha 1. This is, if you take 0.1 common, 1 minus alpha 1. Now if alpha 1 is very less than 1, then we can neglect and we can write down 0.1 and we can get that idea. But they didn't ask you this K1 they provided. K2 also they provided. Now for the K2 how we will write down? Now next step, this HX minus, which is 0.1 alpha 1, that will undergo dissociation. Point is clear? H plus and X2 minus. And this first stage is H plus will be the common ion for the second stage. That's why second dissociation will be further retarded due to the common ion effect. That's why if you look at in second dissociation, the whatever the H plus, that will be negligible compared to the H plus in the first dissociation. So that's why Ka2 will be equals to, here if I said degree of dissociation alpha 2, so then here how much will be dissociate? 0.1 alpha 1 alpha 2. Here H plus already you have a 0.1 alpha 1 plus 0.1 alpha 1 alpha 2. Now X2 will be equals to 0.1 alpha 1 alpha 2. Now if you look at K2 will be equals to, if I write down this expression, now with respect to 0.alpha 1 I am neglecting, this is a very small, with respect to this one I am neglecting. Now immediately K2 will be equals to H plus concentration, which is nothing but a 0.1 alpha 1, whereas X2 will be equals to into 0.1 alpha 1 alpha 2 divided by, here HX concentration is, which is nothing but a 0.1 alpha 1. Now immediately here 0.1 alpha 1 and here 0.1 alpha 1 cancel out, and then we K2 will be equals to 0.1 alpha 1 alpha 2. From this equation, if you look at, if this first equation, if this is equals to 1, you do 0.1 and 0.1 is cancel out. Then immediately from this equation I will get 0.1 alpha 1 square. K1 equals to, they already provided 2.5 into 10 to the power of minus 7. Then K1 equals to 2.5 into 10 to the power of minus 7, and already we have a here 0.5. So then immediately what we can get over here? So then immediately here we will get, then your alpha 1 will be equals to, alpha 1 will be equals to, alpha 1 will be equals to alpha 1 square, alpha 1 square will be equals to by 0.1. Now this decimal point and decimal point cancel out. So then immediately we are getting 25 into 10 to the power of minus 7. Then 25 into 10 to the power of minus 7, that means what can we get over here? Under root of 25 into 10 to the power of minus 7. That will be equals to your alpha 1. And then if you keep over here alpha 1 equals to this value under root of, and K2 value is nothing but a 1 into 10 to the power of minus 3. That also if you put over here, then immediately you will get over here, the situations. If you look at K2 is 1 into 10 to the power of 1 into 10 to the power of minus 13 is equals to, and here we are getting 0.1 into alpha 1, 0.1 into alpha 1, 0.1 into alpha 1. You have to find out this concentration. From this equation I have to get the alpha 2. Okay, fine. Then 0.1 alpha 1 value is under root of 25 into 10 to the power of minus 7 into alpha 2. Then alpha 2 will be equals to, you look at, alpha 2 will be equals to here 1 into 10 to the power of minus 13 by 0.1 into 25 into 10 power of minus 7 under root. This is your alpha 2. Now your x2 concentration is nothing but a 0.1 alpha 1 alpha 2. So then immediately 1 into 10 power of minus 13 by 0.1 alpha 1 is under root of 25 into 10 power of minus 7. This is your alpha 2. This value we put it the alpha 2, then 0.1 into alpha 2 already write down. Alpha 1 is under root of 25 into 10 to the power of minus 7. This is your alpha 1 into 0.1. Then 0.1 cancel, under root this is cancel. Then you look at the calculation. What you are getting the value? 1 into 10 to the power of minus 13. So that's why your answer, what is the x2 minus concentration? x2 minus concentration finally is coming 1 into 10 to the power of minus 13. Point is clear, which is nothing but a 0.1 alpha 1 alpha 2. That means as simple as that you understood. From K1 expression we calculate the alpha 1. Once we got the alpha 1, K2 expression we keep it up and we got the x2 minus concentration is nothing but a 0.1 alpha 1 and alpha 2. From this equation if I keep the alpha 1 value, then we got the alpha 2. Then what is x2 concentration? x2 minus is a 0.1 alpha 1 alpha 2. If you keep, then immediately you will get the value. K2 is nothing but a your x2 concentration, which is nothing but a 1 into 10 to the power of minus 13. Point is clear? Okay. Let us, very nice problem, good problem. Now let us look at the question number 6. What will be the ratio of wavelength of third line of Paschen series to the second line of Balmer series? So that very easy questions. You look at how can we explain this one. First let me clean up these things, then you can go for the understanding of that one problem. Is it clear? Okay. First let me clear the things properly, then we will go through the explanations of that one. Is it clear? Huh? Okay. Let us look at. Now you look at what will be the wavelength of third line. Third line Paschen series means Lyman, Balmer, Paschen. Whenever electron is coming from higher energy orbit to the n equals to 3, orbit 3, that is the Paschen series. First line means 4 to 3 transition. Second line means 5 to 3 transition. Third line means 6 to 3 transition. Then immediately we know 1 by Paschen series. Paschen series will be equals to 1 by lambda. Wave number will be equals to hydrogen atom telling R into Z square. R is a Rydberg constant. So Z square equals to 1 square. 1 by lower energy N1 square minus N2 square. Lower energy means 3 square minus higher energy means 6 square. This is your third line. Now then second line of Balmer series. Balmer series, this is the third line. Third line of this one Paschen series. Then second line of Balmer series. Balmer series means all higher energy orbit to n equals to 2 electron is jumping. So then immediately here 1 by lambda. First line means 3 to 2 transition. Second line means 4 to 2 transition. So then immediately here R 1 by N1 square lower energy 1 by, this is the second line. So that's why here there will be 4 square. Now you look at, they are asking what will be the ratio of wavelength. Here you will get lambda. This lambda by this lambda if you take, that will be the ratio of that one. That was the question. Now next questions if you look at. Next questions what they are telling. Next questions, if you look at, we will go for the next questions. Next questions, very nice questions. Next questions you look at. Potassium dichromate is heated with a KCl in presence of H2SO4. Find the correct match. Dichromate, KCl is there. That means it's a taste of chloride. Whenever chloride salt is treated with a dichromate in presence of concentrated H2SO4, it's a chromyl chloride state, my dear student. You are getting reddish brown vapor, which is nothing but a CrO2Cl2. CrO2Cl2 reddish brown vapor, where there is a chromium is in +6 oxidation state. This will be your structure, my dear. So that's why chromium is in which oxidation state? +6 oxidation state, and it's a chromyl chloride taste reddish brown vapor will come. In this chromium chloride, if you give here NaOH, you know this reaction, this will form a sodium chromate yellow solution. Here if you give a lead acetate, you will get the lead chromate yellow precipitate. Very famous qualitative analysis test. Is it clear? Now that's why which option will be the answer? First option, CrO2Cl2 and +6 oxidation state. Now here they are giving question number 8. You look at osmotic pressure of a solution is 12 atmosphere. What is the concentration of NaCl solution which is isotonic to the given solution at 900? It should not be 900, it is nothing but a 300. Okay, so it is not a 900, it is a 300 K. So then immediately osmotic pressure of a solution is a 12 atmosphere, and that is a isotonic with a NaCl solution. Now if you look at, then immediately isotonic means their osmotic pressure will be same. So that's why the osmotic pressure is a 12 atmosphere, and osmotic pressure will be equals to pi will be equals to CRTI. C is a concentration, R is a universal gas constant, T is a temperature in Kelvin scale, I is nothing but a Van 't Hoff factor. So then for the strong electrolyte, I equals to N, that means the number of ion produced by one molecules. So then if you look at over here, then 12 will be equals to concentration, they are asking C into R. R is 0.0 liter atmosphere. For calculation easy, you can put 1/12 R value, your calculation will be easy. And then RT, T equals to not 900, it should be 300. By mistake in this question written 900. So CRTI for NaCl, I equals to how much? 2. From this expression you will get the value of C, that is only they are asking. One equation, one unknown. Is it clear? Now you look at this question, E cell versus temperature plot they are asking. E cell versus temperature plot, if you look at, first let me rub this one, then only I will explain nicely, you will understood clearly. Now you look at, so first let me rub these things, and then you will understood the things very clearly. Already you know one side question is there, that's why other side I am writing, so that you can understood and you can observe the question also. So then if you look at over here, now E cell versus temperature plot, we know Nernst equation, E cell will be equals to E naught cell minus, and let me show in detail first, so that you can understood these things very clearly from where this Nernst equation is coming. Then delta G will be equals to delta G naught plus RT ln Q. At equilibrium, you know Q will be equals to reaction quotient, that should be K equilibrium. Now delta G equals to minus NFE, that's why minus NF E cell, and then this will be minus NF delta G at standard state, which is nothing but a E naught cell, which is plus RT ln Q. And now if you divide it by minus NF all the way, then what you are getting? E cell will be equals to E naught cell minus RT by NF, and here ln Q. Now if you look at, they are telling E cell versus temperature plot. Now E cell is my Y, then this will be my C, and this entire part minus this slope is a negative slope, and this entire part will be your this entire part except t, this entire part will be m, and then x. Y is equal to mx plus c, straight line equation. Intercept is positive, slope is a negative. Then how your plot? Very simple. So then E cell versus temperature, if you plot, then y intercept is a positive, slope is a negative, it will be like this plot will be there. That's why like that, where will be your plot? E cell versus temperature, that will be your answer. Point is clear? Okay, come to the next question. Next question was very nice question. CH3Br they are giving CH3Br like that. Here I am writing. Look at CH3Br nucleophile they are giving, and then nucleophilicity order asking. The question is giving OH minus, CH3CO minus, PHO minus, and ClO4 minus. Then nucleophilicity order based on the this is a SN2 reaction. If nucleophilicity is more, the rate of reaction will be more faster. Then OH minus is a better nucleophile compared to PHO minus, because PHO minus there will be O minus, the negative charge will be dispersed in a benzene ring. But whereas CH3CO minus is a equivalent resonance, where PHO minus stability only via resonance, and ClO4 minus there are 4 equivalent structure. So we know the aromaticity is greater than equivalent resonance is greater than the normal resonance effect is greater than the hyperconjugation effect, hyperconjugation is greater than the inductive effect. All these electronic effect will explain the stability or instability of intermediate. So now as here there is a negative charge is there, if the dispersion of charge is more via the electronic effect, the stability of the species will be more. If stability is more, nucleophilicity will be less. That's why OH minus is least stable, higher nucleophile. The nucleophilicity order will be OH minus is greater than, PHO minus is greater than, CH3CO minus is greater than, ClO4 minus. So that's why second option is ready. OH minus is greater than, PHO minus is greater than, CH3CO minus is greater than, ClO4 minus. This was the questions. Now come for the next question. In the next question, if you look at carefully, they are giving nitrobenzene. In that nitrobenzene, bromine FeVr3, that means it's a bromination. Meta-directing group, nitro is the electron withdrawing meta-directing group. What will be your A? Meta-bromo nitrobenzene. So you will get your A. SNHCl means nitro will undergo reduction. What are the steps? Yesterday also they give this type of one question I discussed. NO2 will be converted to NH2. What are the steps? Via NO, then NaOH, and then it will be NH2. So then immediately you will get this B is nothing but your NH2Br. Now they are giving bromine water. NH2 is an ortho-para orienting group. With bromine water means all ortho and para with respect to NH2, that will be filled up by electrophile, that means bromine. So then C will be nothing but your NH2 already meta position with respect to one bromination was there, but with respect to NH2 all ortho and para will be bromine. That's why C will be this one. Then NaNO2 dilute HCl 0 degree to 5 degree centigrade, diazotization reaction. Then D will be nothing but a benzene diazonium chloride. Only in a low temperature this will be stable, otherwise corresponding phenolic compound will be formed if the temperature is higher than the 5 degree centigrade. Point is clear, huh? And then you will get over here this compound will be your D. Then CuCl HCl. CuCl HCl means diazonium CuCl HCl, Sandmar reaction via radical pathway. So that's why E will be nothing but your compound. E will be nothing but your here chlorine, here bromine was there, here bromine was there, here bromine was there, and here bromine was there. This will be your E. They are asking what is the E. Point is clear? Okay. Go for the next questions. Now if you look at the next question, they are giving over here for a first order kinetics A to B plus C. Actually both will be gases. A also gases. In the question they give mistake because by memory based question, because question not released till now by the NTA, it is coming from the mouth of the student. That's why some mistakes will be there. So now if you look at here, what is the situation? A is converting to B plus C. If it is gas, homogeneous gaseous reaction. Initial pressure of A is 1 bar. Initial pressure when time t equals to 0, this is a 1 bar, this is 0, 0. Now, at time 100 seconds, the total pressure of the system is 1.5 bar. So that means at 100 seconds, here this is 0.5 if disappear, then you will get here 0.5, 0.5, then only total pressure used to come how much? 1.5. That means pressure 1 to it is coming to the 0.5. That means how much disappearing? That means it's a half amount disappearing. It's like a half-life. And this is a first order kinetics, you know. This is a first order kinetics, already they told. You know that either in terms of a concentration or either in terms of, in case of a gaseous reaction, in terms of a pressure we can consider. In case of a concentration given, we can consider concentration. So now after 100 seconds, pressure is getting half of the reactant. So that's why if you look at 100 seconds is your T half, then T half will be equals to 100 seconds. Directly I can write down. Then immediately K will be equals to, for they are asking the rate constant, then K will be equals to, for first order kinetic, 0.693 by T half. Then 0.693 T half is 100, 0.693 by 100, which is nothing but I can write down, this is your, another 3 will become 30 if I take, another 30 if I take, this is a 30, that means 693 into 10 ki power of minus 5. Now what I can do over here, if I multiplied with 100 here with this, if I divided by 100 over here, if I divided by 100 here, multiply with 100, then what I will get? 6.93. If you look at this calculation, we will get how much? 6.93 into 10 ki power of minus 3. That was the option. Then your answer will be 6.93 into 10 ki power of minus 3. Directly we got it, directly. Now next question you look at. Here, energy of a first line of a Lyman series. That means what I will do, I am telling you the concept, you can check it out. What I have to do, I know the first line of a Lyman series. First line means 2 to 1 transition. So that's why 1 by lambda I will get, 1 by lambda will be equals to R into hydrogen atom means ZA square will be 1. So then R into 1 by lower energy means 1 square minus 1 by 2 square. From there I will get the lambda in terms of a R. And now next same way, energy of second line of a bomber series. Second line of a bomber series means 4 to 2 transition. Then say there also I will get the lambda. Then first line of a bomber series. First line of a bomber series means 3 to 2 transition. There also I will get the lambda. And energy of a second line of a Lyman series. Second line means 3 to 1 transition. There also I will get the lambda. If higher is the lambda, energy will be the lower. Lambda and energy are inversely proportional. Energy is directly proportional to frequency. Lambda is inversely proportional to frequency. If lambda is more, energy will be less. If lambda is less, energy will be more. That is the funda. Based on that, if you get it, you will get your fourth options will be your answer D, greater than A, greater than B, greater than C. Let us go for the next questions. If you look at the next question, here they are telling which compound is optically inactive out of the following. Now if you look at N-propyl chloride. N-propyl chloride means normal propyl chloride, my dear student. CH3, CH2, CH2, Cl. This is a structure 1. There is a no chiral center. There is a no question of optical activity. These are optically inactive. Secondary butyl chloride. What is secondary butyl chloride? CH3, CH2, CH, CH3. This is a secondary butyl group. Here chloride. Now you look at here chiral center is there. Then second compound is optically active. Now tertiary butyl chloride. Tertiary butyl group is this one. Tertiary butyl group is this one, and with that chloride there is a no chiral center. 3-methyl group is present. This is optically inactive. And then isopropyl chloride. Isopropyl group is a CH3, CH, CH3, isopropyl chloride. There is a no chiral center. So that's why there is a no question of optical activity. Then your 1, 3 and 4 are optically inactive. This is optically active. This is optically inactive, optically inactive, optically inactive. Then your which option will be answer? 1, 3, 4. Let us look at the option. First option is ready. 1, 3, 4 is optically inactive. Then question number 15 they are giving, which of the following statement are true? Manganese has a highest oxidation state in Mn2O7. MnO is more basic, that is correct. Manganese is in +7 oxidation state. MnO is more basic than Mn2O7 because Mn2O7 is a covalent in nature. Mn2O7 has a one bridging oxygen atom. Yes, manganese Mn2O7 structure will be like this, my dear student. There will be like this situation, Mn2O7 structure. So that's why this will be the structure. So that's why one bridging oxygen atom is present. So oxidation stage of manganese is generally maximum in oxo compound, and that oxo compound definitely with oxygen and fluorine, the transition metal atom used to show the highest oxidation state. That's why if you look at that 1, 2, 3, 4 all will be your correct options. Come for the matching questions. What is Etard reaction? In Etard reaction, if you take the toluene and treat it with a CrO2, Cl2, CH2 and H3O, then you will get a benzaldehyde. So that's why A will be matched with a fourth one. Gattermann-Koch reaction means benzene if treated with a CO, HCl, AlCl3, you will get a benzaldehyde. So that's why Gattermann B will be matched with a 3. Stephan reaction means cyanide if you treated with SnCl2 and HCl and hydrolysis, corresponding aldehyde you will get. Rosenman reaction means acid chloride RCOCl if you treated with a H2PDBaSO4, corresponding aldehyde will be formed. So that's why D will be matched with a 1. Now you look at the option. A is connected with a 4, B is connected with a 3, C is connected with a 2 and D is connected with a 1. That's why second options will be the answers. Now come for this question. SnCl2, SnCl4, PbCl4, PbCl2, UF6 and UF4. Which are they are asking in which of the following pair first compound has the more covalent in nature. The idea is if metal ion is present in the higher oxidation state, then polarization power will be more. If polarization power is more, it's a Fajan's rule number 1. If the polarization power of cation is more, then it will polarizes the electron density from anion towards itself will be more, sharing of electron will be more, covalent character will be more. So that's why in case of first one, if you look at tin is in their +2 oxidation state, second one is in +4 oxidation state. Which of the pair they first have a more covalent? In case of option A, second one is more covalent. In the option B, first one is more covalent, lead is in +4 oxidation state. Whereas in the option C, first one is more covalent, uranium is +6 oxidation state. B and C will be your answer. First one will be more covalent compared to second one, not the your first options. Go for the next level of questions. You look at 18th questions. 18th question is a very nice question. Actually, this question is based on little advanced concept is associated with this. If you want to understood this question, first you need to understood one idea. Then only you can able to understood this question. Actually, these are advanced level questions. Now, if you look at first, if I take a one galvanic cell based on the electrochemistry galvanic cell problem, because you know galvanic cell is nothing but a electrochemistry is essentially interconversion of energy, interconversion of chemical energy to electrical energy as well as electrical to chemical. So that this chapter deals nothing but a interconversion of chemical to electrical as well as electrical to chemical, as simple as that. For the conversion of energy you need a device. Galvanic cell is that device which can convert chemical energy to electrical energy, whereas electrolytic cell is nothing but that device which will convert electrical energy to chemical energy due to passage of electricity, chemical reaction taking place. But here we need a galvanic cell concept. Now in galvanic cell I am taking one anode and one cathode will be there. So then anode I am taking Ag to Ag plus and double Dacard salt bridge, and here I am utilizing soluble anion, sparingly soluble salt or insoluble salt, and metal acting as your cathode. Now here they are giving these things E0 of Ag plus 2, Ag plus 2, Ag plus 2 Ag is 0.8 volt and supports your KSP of AgCl, that is they are giving 10 power of minus 10, and then they are asking E naught of Cl minus AgCl and Ag, that value equals to how much they are asking. Now this was the problem. To do this problem, first you understood this methodology. Now you look at what I can do. Here metal ion, that means metal soluble salt of that metal ion acting as the anode, whereas soluble anion, insoluble salt or sparingly soluble salt, and metal acting as a cathode. This type of electrode is like a calomel electrode. So now first what you need to know, whenever that type of electron acting as a cathode, you just remember one sign. That means one short, so that you can write down the reaction. So cathode means the reaction from middle, these things will go toward this side. So anode, what reaction is happening? Anode means oxidation, vowel for vowel. So that's why Ag will be converted to Ag plus by loss of electron. This is your anode reaction, and this is a solid, and this is a aqueous, and this is a anode silver ion concentration. Now cathode means what? Reduction. So then immediately cathode, what is happening? AgCl is converting to what? Ag and Cl minus. AgCl is taking one electron, converting to Ag, and Cl minus is free. That means this is a solid, this is a solid, chloride ion concentration is aqueous. This is a cathode. This was your reaction. Now immediately if I write down the Q expression, Q will be equals to silver ion concentration add anode into chloride ion concentration add cathode. Otherwise all our things are what? Solid. There is no issue. So this is your Q. Now come to the next page. Then only we can explain very nicely. Then immediately if I charge the nonce equation, E cell will be equals to E naught cell minus 0.06 by n, 1 electron change, log of Q, log of silver ion concentration at anode into chloride ion concentration at cathode. Now you look at add equilibrium. Add equilibrium we know very well, delta G 0, but delta G naught may or may not be 0. So same way E cell will be equals to what? 0, and E naught cell may or may not, based on the situation, may or may not, may or may not. Now E cell equals to if you 0, and another thing will be there, as this is like a concentration cell, that means silver ion is their anode and silver ion is there in cathode. Whenever there is a no concentration gradient, then only they reach the equilibrium. If concentration gradient is there, then electron flow will be there from anode to cathode to make the equalize the concentration of Ag plus in both the compartment. So now at equilibrium, silver ion concentration of anode as well as silver ion concentration cathode will be what? Equal. So that we can write down silver ion concentration anode will be equals to silver ion concentration add cathode, then only reaction will stop, no concentration gradient, add equilibrium. Then immediately from nonce equation what I can write down, E cell will be equals to 0, E naught cell minus 0.06 log of, instead of silver ion concentration anode I can replace it silver ion concentration cathode into chloride ion concentration cathode. Then immediately E naught cell will be equals to, E naught cell means E naught cell equals to, I can write down 0.06 log of silver ion concentration cathode into silver ion chloride ion concentration cathode. I am writing KSP of AgCl. Funda you understood. If silver ion concentation at anode is there, we cannot write down that thing equals to KSP. But if it is there silver ion concentration cathode into chloride ion concentration cathode, then only I can write down these things. Now immediately E naught cell will be equals to E naught of oxidation, means E naught of oxidation plus E naught of reduction equals to 0.06 log of KSP of AgCl, log of KSP of AgCl. E naught oxidation I can write down E naught of Ag to Ag plus, and E naught of reductions we will put it E naught of Cl minus AgCl and Ag will be equals to 0.06 log of Ksp. Now if I take this thing this side, what I can write down? E naught of Cl minus AgCl. Ag will be equals to your minus of E naught Ag to Ag plus 0.06 log of Ksp of AgCl. So that means minus of oxidation potential means plus of reduction potential. E naught of Ag plus 2 Ag plus 0.06 log of Ksp of AgCl. We will get, this is your expression. That means E naught of Cl minus AgCl, Ag will be equals to, this will be your expression. Now same way they give the problem. If you look at the same way they give the problem. So they are asking over here E naught of mx x minus. That means whatever the data they provided, Ksp of the provided, directly what you will find out? Directly you will find out E naught of x minus and mx and m, that will be equals to E naught of m plus 2 m and plus 0.06 log of Ksp of mx. Whatever if the data they are giving, you will get this electrode. That means if it is acting as a cathode, make it reverse, make it minus, immediately you will get the E naught of mx x minus. I hope I able to make it give the clarity. Okay, I hope you understood. Then there are direct some question is there. This question is very good. 5 gram of solute is dissolved in a 250 gram of benzene. Delta TF 0.5 can relative lowering of vapor pressure. What you have to do? First you have to do delta TF will be equals to Kf into delta TF will be equals to Kf into delta TF will be equals to Kf into molality into I. So molality is easily you can calculate number of moles of solute by weight of solvent in kg, and then you will get the I value. Once you will get the I value, relative lowering of vapor pressure they are asking, delta P by P naught will be equals to mole fraction of solute, and then number of moles of solute by number of moles of solute plus number of moles of solvent. Wherever number of moles of solute will be there, you have to multiply it by I, then you will get your values. And 21 question, it is clearly based on the formula. That means 2 into atomic weight of phosphorus, that means which is 31, into how much Mg2P2O7 formed by molar mass of Mg2P2O7 into weight of organic sample into whole into 100, you will get percentage of P. And now the last few questions, you have to calculate the number of unpaired electron in the all the species. Nickel plus 2, there are 2 unpaired electron. Iron plus 2, there are 4 unpaired electron, D6 configuration. Nickel is D8 configuration. Cobalt plus 3, cobalt plus 2, there are 3 unpaired electron. Vanadium plus 3, vanadium means scandium, titanium, vanadium. So then scandium, titanium, vanadium means D3, D2. So D3, D2 means 3 plus 8 means 2 unpaired electron. Titanium plus 2 means you have a 2 unpaired electron. Based on the unpaired electron, you have to apply the formula under root of mu equals to under root of n into n plus 2, and based on that you have to check it out which has the how many species has the less than 3 Bohr magneton spin only magnetic moment. These are the concept. I hope I able to give you full clarity on the paper discussions. Coming days, coming sessions, discussions also will be there to understood and to get the clarity about the every questions and the associated concept. Please watch, follow, like my channel so that channel can prosper and go. Thank you very much. Thank you all, and best wishes to the student whoever is going to upcoming session exam. Thank you all.